Welcome to Matematika. Today we're going to do problems and solutions of 1.5b, polynomial functions and complex zeros. We'll start with the first set. Determine if the following function are even, odd, or neither. 1. F of x is equal to x to the third power plus 3. So as I've said, the first thing that I have to look at is look for the degree of the function. Like here, the degree is 3. I could firstly say that this is odd, but I have to verify and check if it goes with the rules of having an odd function. Okay, let's verify. When you say it's odd, so the f of negative x would be equal to the negative of the function of x. So I go straight to, without substituting the negative x, because I know it's not, quietly sure I know it's not even. So I could go directly and making the function into a negative. So making x cubed plus 3 and put a negative in front of the function. So if we try to expand negative times x cubed, that would be a negative x cubed. Negative times a positive 3, that would be a negative 3. That's what I mean in this case in the video yesterday. So I could say, see, it's negative, the opposite of positive here, and negative 3 is the opposite of positive 3. So I could say that the function of negative x is equals to the function of negative of the function x. So this is odd. All right, let's do this question. F of x is equals to negative 6x to the fifth power plus 15 x cubed minus 9x. If we try to look at the degree is odd. Okay, I go straight and check. F of negative x, I check if it's a negative of the function x. So what I'm going to do, since I have two terms that has a power here, I would say that I will, substitute the negative x first in the function, plus 15x to the negative x cubed minus 9 times a negative x, and try to check. Negative x to the fifth, that's odd, that will be a negative, times a negative, that would become a positive 6x to the fifth. A negative x cubed is a negative times 15, that's a negative 15x to the third. A negative 9 times a negative x, that would become a positive 9x. So what do we have? Positive 6, negative 6 in the given, negative 15 plus 15, negative 9, positive 9, negative 9x. Therefore, it is the negative of the function. So I would say that negative, I will put in front of the function, plus 15x cubed minus 9x. So both negative and negative, you will have positive 6x to the fifth power minus 15x to the third plus 9x. So I could say that the function of negative x is equal to the negative of the function of x. All right, you have that. Because this is the negative of the given function. Okay, let's do number 3. p of x is equals to the square root of 6x to the fourth power minus square root of 11x to the second power minus square root of 5. So constant in any function can be written as like the constant times x to the 0. So which means that the degree of any constant is 0. So this shows that all the terms in the equation have a degree that is even or 0. You see that? Okay. So to confirm, we try to check algebraically that the function is even. So we need to show that the function of a negative x is equals to the p of x. Okay, so we're going to start. I will substitute the negative x to the function. Okay, minus square root of 11 times negative x squared minus square root of 5. Okay. Negative x to the fourth, that would become a positive. So you have 6 square root of 6x to the fourth power minus negative x squared, that would be a positive. So square root of 11x squared minus square root of 5. So what do we have here? Isn't it, it's the same as the given function? So therefore you could say that p of negative x is equals to the p of x. So this is an even function. Okay, because it's equal to the original function. All right, let's look at this fourth question. Certain values of g of x are given in the table below. That g of x is odd. Fill in the missing values in the table. Okay. All values of x are odd values. I have to do like observations here. So if I look at here, this is a positive 7 and this is negative 7. I think this is a very, very easy to fill in by doing an observation. This is a negative and this is a positive. Therefore, this might be, the middle, the symmetry. I'm trying to get if it's symmetrical. Okay. So this is negative 7, 5, 9 to the right side. To the left, it's positive 7, then negative 5. So I assume that prior to negative 5, it's negative 9. So that means this would be a negative 9 here. Right? Negative 5, 7, negative 9. Negative 7, negative 7, 5, negative 5, 9. So this will be a negative 9. So whatever coordinates we have, in negative 7, the coordinates is 22.5. Then I could say it's negative 22.5. Okay, because I have here negative 38.5, and when it's 9, it's 38.5. Therefore, if this is 10.5, this would be a negative 10.5. Just look at how it goes without getting the interval of its, x values. They're equally interval. But the g of x is also equally interval. By looking at it in the process of one after another, then it's without anything that is for certain that that's the value. Okay, so let me say this. If I can do it, so can you. Okay, please don't forget to hit the like button and hit the subscribe button. See you in my next video.